Kevlin Henney, technical neglect. This is part 2. Hello, I'm Chris Athanas. I'm a KMP developer. Today I'm going to be doing part 2, which I'm recording for the second time because I forgot to hit the record button. So hopefully this will be fresh enough. And yeah, tech support, they're going to close that up. They said it. They promised. I got this thing back here. Let me move this out of the way. All right, let's continue on with the Kevlin.
It's like driving with the brakes on. Okay, you're in the wrong gear. You are going slow, and you're still making. That boat is sinking, isn't it?
What the hell? Hold on. All right. Yeah. So this 80% of the costs are in keeping these things maintained. So they're not. My big gripe is these operating systems and IDEs, languages, and all this other stuff was not built for the maintenance. It was built for the building of it. And yes, we can get these things up and running, but maintaining them and documenting them and making them easy to read and understand all that stuff, we still haven't achieved that yet. That's where most of the costs are at. And no one is really talking about this stuff except Alan Kay back then. He was like, hey, man, this is going to become a major problem. You're going to have to build this into the operating system from the bottom to the top, this concept of encapsulation and stuff. And then people are like, no, we can just skip that for the performance.
Legacy technologies hamper efficiencies and restrict growth in an estimated 88% of businesses. So that's the thing. It's preventing you. It eliminates your options.
Right, and also this is a great opportunity because these businesses they don't have a solution for this, and they don't want to start over. So small, scrappy businesses could get together and they could slice off pieces of niches of these businesses because they can't move. They're stuck. And if you can slice off their customers and have provisions in place where you're going to be rolling over a code base at least every couple of years just to keep the parasites off of it, and just realize that's going to be part of the cost, and you know. Integrate that in somehow. Yeah, these businesses all are open for what disruption, which means destruction. So let's keep going.
It doesn't cause you to not be able to have a business, but what it does is it's like driving with the brakes on.
Well, like I just said, with these AI tools and smaller teams, and they taking these things into consideration, these big businesses are open to competition. They will lose their businesses.
Okay, you're in the wrong gear. You are going slow, and you're still making some kind of progress.
You hope you're doing it faster than some other scrappy startup that says, I think I'm going to take that guy's lunch. I think I'm going to take a slice of his business, a little piece of the niche that they're get involved with. I'm going to talk to those people, figure out what they want, and I'm going to build up a solution that's going to fix a piece of this, or fix a part of it, or fix some chunk of it, or just start the fixing process where you've pissed off so many people without you're not responding to their needs. I'm going to serve those customers and take that business away from you.
It requires a lot more effort. That's what's going on. So we need to talk about the creation of legacy code. How does it happen? Well, specifically, I'm not going to talk generally about the creation of legacy code. Well, we'll do in a couple of minutes. But this is taken from, it's 2024. Is this even a talk if I don't mention AI? Of course. There we go.
Yeah, of course. You got to say something about it.
That melted the icebergs. Yeah. The practical consequences of using LLMs to generate code is that many developers will find they have unwittingly moved themselves into a role they were probably trying to avoid. They have automated the creation of legacy code.
Yeah, that's it right there. Okay, it generates it, but do you understand it? Can you modify it? Can you fix it? Can you update it? Can you extend it? Do you know why it's failing? Where it's failing? For what reason? What corner case it omitted? Because you didn't ask it to have that corner case?
It's somebody else that wrote it, right? You didn't write it. So you have just created legacy code. Well done.
I love that. So I didn't hear that the first time through. Yes, with the LLMs, we are immediately creating legacy code. We're creating stuff that we don't fully understand. This is how most people allow it. Now, professional developers, they won't allow that. They'll curate every damn thing as if they had written it themselves, and they have to make sense of it before they let it go through. Sometimes they can do it pretty quickly. Sometimes they got to slow down and let it percolate. But there's like the LLM prompters are just like, no, this is good. This is great. Get this thing out the door. Let's get this Fiverr ticket done.
Full metaphor. It's an own goal. You just scored a goal, and it was yours. It's not the other team's, it's yours.
Scored on his own goal. Whoops. Damn it.
And redefine their job as debugging and fixing such code. Now, this is really interesting because that's this. I said this just over a year ago, April 23.
It's very prescient. Kevlin's He's been down the pit. He looks like he's actively coding on projects because he's understanding what the limitations of these things are. He's not just pontificating about the past, like Uncle Bob. I don't know if Uncle Bob's actually doing coding these days. I think he's just trying out these tools on little toy projects. I think Kevlin's in the pit actually getting stuff done. Here we go.
I kind of like put this out there. I'm not saying that everybody's doing this. Notice I say many. I reckon, I'm going to pick some random numbers. I have no evidence of these numbers just at this point, but I'm just going to be very generous, and I'm going to say 10% of developers are not in this. 90% are. 10% are doing a really good job. They understand exactly what it is that AI can and cannot do.
Yeah, that's what I just said.
LLMs.
It's like a code completion, but it's the completion has to still be complete for what you want, not just, oh yeah, that sounds great. It's like if it was the code suggestions, if you just took everyone, no matter what it was, oh, that's fine, it sounds good, even though it may not fit in with the context of your letter or your assignment or whatever the hell you're doing, your email. No, that's good. It sounds great. It's like, no, man, that doesn't. That's not how this works.
To explore things, to get suggestions. They are integrating them into their own thinking. They're not just going, copy paste, or just put it in straight into my source file. They're looking at it deliberately. I know what I'm expecting. I have already written tests. And I'm evaluating. In other words, human in the loop. I'm using it to give myself an advantage. The problem is that most people are not giving themselves an advantage. They are giving themselves a disadvantage, and they don't know it.
Yeah, man. That's what's coming true. That's been validated. I think he shows a study here in a second.
They are getting the sense that, oh wow, I'm being so productive because it's generating so much code. Lines of code, not a useful measure. They are getting a sense of progress that is a lot like, well, when you sit in a train and there's another train adjacent to you, you know this feeling. The other train moves and you think you're moving. Yeah, that's called vection. So what we're having is a lot of vection.
That's neat, fun.
Which also creates a lot of vexation. So there was an interesting, so this is the thing that I found interesting. I said that last April. January, there is a study from GitClear about coding on Copilot. 2023 data shows downward pressure on code quality, 150 million lines of analyzed code.
I don't know how they do this code quality chart thing, but I like the title already. But how they measure this? Let's see what he has to say.
Corrections for 2024. So okay, this is a fairly decent data set. But what was fascinating is it's there in the subtitle: downward pressure on code quality. Basically, they're saying, okay, here's the AI era, and whoo, here comes the code churn. We find disconcerting trends for maintainability. Oh, so if you're wondering if your job's safe,
as if it was already bad to begin with.
Totally safe.
It just says James House job safety because now it's all legacy. The moment it comes out of the machine, it's legacy. It's like we're all legacy engineers now. If you're a prompter, you're a legacy engineer.
It's absolutely safe. As long as you're a legacy code programmer, yeah, and create your own legacy.
And you're good.
Yeah. Code churn, the percentage of lines that are reverted or updated less than...
that's what I wanted to say. I want to make sure I made that point. We have to remember what happened when these people thought they could just replace developers with AI. They got rid of it super fast. We have to remember that. So if you're going to be like attacking these companies, realize a lot of their employees are like kind of gunning for you. And if you're going to be working at these places, just realize the moment they think they can get rid of you, all they live, they're talking about family, and we all have values here. We really want your progression as an engineer, and you want to have your career in mind. And then the moment the interest rate blips up 0.5%, or the moment they sniff that it's possible to get rid of you with AI, then you're out the door. Like, get the hell out of here. And then it's like, hey, wait a second, what the hell? I thought you guys were our valued property. I thought you were a valued resource. Or our people. Nope, turns out they think it's just the machine doing the output. So let's not forget that. Let's not get ahead of ourselves and forget that they did that, and then they're just to come back. It's like, oh, we're going to be a little bit more expensive if you want us to do this other stuff. You want Code Monkey? Yeah, you got a Code Monkey. All right, the prompters. But if you want this stuff done together and keep it maintained and all the stuff that you want to think this stuff is going to help you with, you got to either pay a lot more money or you're going to just be open to direct competition.
And 2 weeks after being authored is projected to double in 2024 compared to its 2021 pre-AI baseline. There's a small number of people who are really absolutely tearing this one up and doing a great job and getting such an advantage because they understand exactly how to work with the tool. There's a lot of people...
Yeah, they understand the limitation of the tool, what it's for, how it works, and also that you have to be a human curator. It may generate the code, but you still have to curate it, which means that you have to understand it's fit for purpose for what you're trying to do at that particular moment. And most of the time, it's wrong. Let's be real honest about it. Most of the time, it's wrong, but every once in a while, it's easy. I mean, I'd say like 40% of the time, it's like on it the first time, but you have to massage it. And it's easier than going to Stack Overflow, which is always the next one to go to, or the damn manual, which is Gradle. Come on, stop.
Who are not, and unwittingly so. You don't always see the problem. We further find the percentage of added code and copy-pasted code is increasing in proportion to updated, deleted, and moved code. That's a really interesting observation that they make. They're not just looking at code churn. It's the characteristics of how do I know that a refactoring or a change is good.
Right, because the prompting allows the generation just to go off of this. Yeah, that makes sense. But a lot of the things we do as a software developer to keep the maintainability is updating, deleting, and moving things. That's the stuff we're doing, and reading it, and understanding it, how it fits into the whole thing. And that's why Alan Kay is like, you can only do that for so large, until the complexity gets to be too high, and you have to encapsulate it just to keep the system manageable. And we're expecting humans to not do that. And it's like, man, we're gonna have to listen to Alan Kay eventually.
Things by, oh well, yeah, we deleted this, we moved it. A lot of good refactoring is about moving responsibilities around. It's just, oh, that doesn't belong over here. That's duplicated over here. Maybe there's an idea we missed that's in the middle. Let's move that there. Create a new concept. There is a class that is sitting there, or wanting to be noticed. There is a responsibility kind of lurking between these two objects that wants to be reified, to be made real. And so that's what we're after. There's a lot of movement. We update in place. We delete. But just the process of addition and copying and pasting, that is a sign that is not so healthy. And what is interesting is, if I recall the opening of the paper correctly, they basically said, the question we're asking is working with an LLM like working with a senior developer who's mentoring you and has deep knowledge of your code base? Or is it...
I'm going to answer the question. Let me answer it. It's sort of like having someone that has deep knowledge of the techniques that are been used for similar things, but they have no idea what you're trying to do with this thing at all. No concept of what you're actually trying to do, provide. What's the new thing, your product service you're providing to do a solution that really hasn't been addressed yet, because this is why you're writing the software.
Like having a short-term programmer, short-term contractor tear through your code base on an hourly
paid rate. Right.
The answer is the latter. In this regard, code generation during 2023
that's what it is.
An itinerant contributor.
If you let that thing run wild, yeah, it knows about how to code, but it doesn't know anything to do with your business situation or the intent you're putting behind it, or any of the things that makes it human and the value add now, which is culture, ethics, morals, attention, care, taste, language, not just the computer language, but the culture of the region, all this other stuff, man.
Prone to violate the dryness of the repos visited. Now, this is not an AI rant. I've just told you where the good stuff is. I've just told you it's in a minority. And we already knew this, because it turns out that tools were not the problem. So here's something I tweeted during the pandemic. One of the great things about languages with modern IDE support is that thanks to refactoring tools, legacy code is a thing of the past.
Right.
It's so great living in the 2020s. We just don't have the kind of legacy code that people used to have. Because, you can just move code around freely. Done.
Yeah, I think he's just saying the same thing I'm saying. It's like these tools are still not fit for purpose for how we're using them and the scale we're using them at. It's just not, we need a whole new revamp. Sorry. The computer revolution is still far off.
It's not a problem anymore. I envy people coming into programming now. They just don't have to deal with legacy code. They never have to experience long methods, random classes, poor identifier names, complex. Yeah, some people responded to this tweet directly without waiting for the tweet after it and the tweet after it. The point is, it was never the tools. The absence or presence of tools was not the issue.
It's still tools about an idea about how to solve a problem, which the moment we solved it using that way, we're like, well, what else can it do? It's like we humans, we just do this. And it's like, well, that was not really designed for this massive thing. We need to simplify some of this stuff, which is kind of what KMP is. What the KMP does is it simplifies a lot of that stuff. So you got one language from the front and back and all the different platforms, Android, iOS, desktop, web, and whatever else comes along.
Whether or not people knew how to use them. And again, there's a percentage of people who absolutely have command over this, but the majority of people don't. And you say, refactoring, and they go, yeah, rename. And if you say, well,
that's the smallest free factor.
Do you use anything else? They say, yeah, sometimes we use extract method. What extract class? That's possible.
Okay, that's not really refactoring. Those are tools to help with a part of refactoring. Most of it's this conceptual model, like where do you put things for humans to adhere to the Conway's law of this business situation, so we can split the work up efficiently, because we're creating a factory. We're trying to create a factory that makes widgets, right? So we're designing the widget and the factory.
Possible. Extract interface, maybe. Yeah, and we haven't even got to the funds.
We might need to put things around, and it might be the machine needs to be tweaked around, but we also might need to move the process around, or how the messages flow. All that stuff. Those tools don't help with that.
The point is, it was never the tools. The tools were not the problem. It is to do with first of all, the knowledge of these things, but also the knowledge and the belief that it's possible. If you're in a place of work where this is not normal, then you pick up by osmosis the idea that you don't do this.
Right, and most of the time we come in these legacy projects, the legacy people, whether the way it's been done is the way we expect it to always be done. And they'll veto anything. It's like, well, why are we doing it like this? We should do this other thing. It's like, no, we're doing it like this. Well, who made the decision? Oh, well, it was Bob, and he was laid off 16 weeks ago, and we haven't heard from him since. He said he was going to come in and do some contracting and fill in some details, but we haven't been able to contact. It's like, okay, well, we're here now on this project. So do we get any say? Well, we just want to fix a few bugs. It just goes on and on and on.
It's just not a thing. Yeah, it's nobody's fault specifically.
That's why these businesses are all open to direct communication, because they all have this attitude.
Nobody's being willful and being bad. So it's a case of this is just how we do things here. And it turns out that adding tools to just how we do things here does not actually fundamentally change that aspect of the landscape. Now, speaking of barren landscape, let's talk about legacy code. For those who are interested, that's a monolithic architecture. This stuff everybody's complaining about, that's not monolithic. That's monolithic, yeah?
Okay.
That's
even though that was a constructed thing, but let's keep going.
Latest technology we have in the UK.
You can look at it. If you don't know it's constructed, you can look into it. Let's keep going.
Post-Brexit. Yeah, silicon-based. Yeah, advanced technology. Classic legacy system.
I mean, it's cool.
No idea
I love it.
Not entirely sure why, but it seems to work twice a year. And nobody's allowed to change it. So let's talk about...
Well, the people that put it there recently, they changed it. But let's keep going, Chris.
Legacy code. That's not really a metaphor. Spaghetti code is not really a metaphor. Spaghetti code is a description of structure, but it is not a metaphor.
Right, it doesn't extend out. It's past the squills. Everything's missed. You can't see where everything's hooked in. You have no idea where things are going. It's a big wired, hairy mess, also called a rat's nest. They have all kinds of names for it, but it's a rat's nest of code, but it's not. There's not real rats in there. They're not eating cheese or falling into traps. Although there's some metaphors there could be extended, right? But it's the overextending of the metaphor which gets issues.
You know, if you're trying to,
or not for the right person, or not understanding the context, or which aspect of spaghetti we're referring to, not the slick, slimy part of it, not the made out of wheat part of it, but the everything interrelated like this part of it. That's the metaphor we're trying to use.
Suggest to me that spaghetti is bad, I will fight you for it. It's my favorite pasta.
Okay.
Okay. So, oh, this is like spaghetti. Oh, awesome, great. What sauce have you got? No, we're describing structure.
Right. We're using people talk the wrong metaphor, the tastiness of it. You mean the code is super tasty? It gives you a nice, yummy feeling after you read the code.
Describing a kind of a feeling or an economic consequence.
No.
That, of course, has not stopped people coming up with all kinds of pasta-based metaphors. You don't want spaghetti. Yes, I do. You want lasagna because it's layered.
Oh, my God.
My favorite one is ravioli. Because when people use ravioli, you can tell how old they are.
Oh, my Jesus.
Because when people sort of say, oh, yeah, microservices. Oh, you're quite young. I have seen ravioli. I first heard ravioli in the early 90s as a metaphor for this. And that was objects.
Yeah, it makes sense. Components. I mean, it's all microservices, objects. It's all the same stuff. Just different words, different context, but the same damn idea. But encapsulated around some code and data or whatever is encapsulated around an API, and you can't bust through it. You have to actually ask through the API. The API may change and update, so there's got to be some mechanism for that, which nobody ever thinks about. Like, I just one of the APIs down, that's it. It's like, come on, upgrading this thing is like the hardest part. Like people are like, well, you just kind of figure it out. It's like, come on, that's the hardest part. Let's keep going.
And then it was services, and now it's microservices, and maybe it's going to be nanoservices next year. Who knows? But the point is, that one seems to change with time.
Functions, lambdas. I mean, it's all the same stuff.
Yeah.
You'll make a big deal like, no, this is really different. No, it's really different. No, it's not. It's really not. Well, it's in a process, and it's one of the other ones that said, no, that's sort of conceptual. Hardware implementation, you don't even know where it's even running. What are you talking about? Let's keep going.
Software decay. These are terms that have been used at various points. These have some of the right suggestion, but they've never really stuck because there is an idea that independently of...
Yeah, the code does never rot. It's like, there's not the software decayed. No, it wasn't updated by humans to keep up with all the other changes that humans had made. There's no rotting anything. Now, the medium might rot. A disk or paper punch tape might fall apart after getting left in the sun or something. Yes, the medium might rot, but the software doesn't rot. It's just everything grows up around it. And if the thing just stays down here, it's frozen in time, which is kind of cool, actually, because you go back to the same computer that was at that time and all the hardware and everything. You can still run that same thing on that same thing, like it still existed that day that happened, the day the guy has hit save, the same exact thing. So it doesn't rot.
Human action, something will rot. It's the idea that nature takes its course, but that's not how software works. You know, you leave a piece of code alone for a long time, and honestly, the curly brackets don't fall off it. wow,
Correct.
this code is so old. Some of the ones have decayed into zeros. That's not how it works.
No.
Whereas we have this idea that these happen independently of that. So it doesn't quite have, it has some of the right things, but there's a really big thing in the middle there that doesn't feel quite right. Software entropy, I've already mentioned. Technical debt, that's one. That's the one that's really caught everyone's imagination. We have a much more niche one, unhedged call option. One of my favorite ones.
Unhedged call option. Technical, no, I mean unhedged call option. That's part of the coding thing. And then that domain totally makes sense. But outside that domain, you're just being a dick, and you're just intentionally confusing people, trying to look like a kind of a big deal. Like that shit. It's like, stop, please. That's not helping.
We'll come back to that one. So, in terms of origins, the debt metaphor dates back to 1992.
I'm glad he goes into this.
It was popularized. So by the end of the 90s, some people, myself included, were using the debt metaphor in describing questions of code and decisions within the code. But it didn't have the name technical consistently. Some people called it technical debt, some people called it design debt.
They had all kinds of words for it. It's crufty, it needs to be fixed, something broke, the new adapter failed because some bit is being set incorrectly on this new blah, 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 blah.
Really, it was around the early 2000s. And this is Martin Fowler's blog at the time, 2003. Unfortunately, he's updated the blog since, which is a shame, because actually his blog, his original version was very much a historical document. A lot of people read it, and it had an influence on people's vocabulary.
Welcome to the internet.
Technical debt is a wonderful metaphor developed by Ward Cunningham, inventor of the wiki. In this metaphor, doing things the quick and dirty way sets us up with a technical debt, which is similar to a financial debt.
Right. So in that thing, so this is only in this context of this job that he was working on at the time. Not Martin, but the other guy. Similar,
but he's not saying it is a metaphor. We're going to come back to that. But the problem that we have is perhaps partly by suggestion, and Martin repeats it a number of times. He uses the phrase "quick and dirty."
Right. We have to do shortcuts. We are intentionally not doing certain things that we're normally going to need to do if we're going to put this thing into production for long-term use. Then we're not going to do those things because we don't even know if this thing's going to be useful or not.
Which is an American English phrase that originated in the earlier part of, it was first used at the end of the 19th century, but it really took hold in the earlier part of the 20th century. And it basically means that something has been done hastily. It's temporary. It's not great, but it'll do for now.
Yeah.
Please don't keep it around. But it's immediately
it's an experiment. It's not meant to go into production. It's an experiment. But then when it works, people go, "Oh my God, it works! Let's put it into production! Like, ship it!" It's like, wait a second, we did a bunch of stuff that's not meant for that. It's like, could you just extend it till the trade show's over?
The quality of it, you're saying something very negative about it potentially. So what's happened is that people often assume that technical debt is intrinsically a negative concept, and that is also reinforced by people's common experience of debt.
I mean, you're doing something to cut a corner intentionally to get something quickly, instead of waiting months and months. If you do every little thing properly, like this thing's gonna go right into production, it won't be quick. It'll be the technology will progress by the time you get that done.
And it's just like, yeah, debt, bad thing. We're gonna see that's not really the case. When Ward actually wrote it up in 1992, interestingly enough, the reason he used the debt metaphor is he was describing the problem to a finance company. So he was using their language. Shipping first-time code is like going into debt. A little debt speeds development so long as it is paid back.
First-time code means the quick and dirty from MVP, proof of concept. He calls it first-time code here, but he's talking about the MVP, proof of concept, just trying stuff out. Oh my God, people care about this? Yeah, I mean, I did a lot of shareware stuff, and most of the stuff people completely ignored. And so I got something that people were asking for. They were saying, "Could you do this?" And I was also kind of interested, so I did a little thing, and they're like, "Oh my God, can you do more of that?" I'm like, "Okay." But the stuff I'd spend all my time and energy and weeks and weeks doing the shareware, I just was molding it and crafting it, and people put it out there. I was like, "Oh boy." And that's when I learned, like, don't do that. I was like, I did that a few times thinking I was smart, and I was like, no, people don't care about that. They only care about their thing. They don't care about your thing. They care about their thing. So do something to help them with their thing, and then you're good.
Back promptly with a rewrite. There you go. Everything you needed to know. It's all there. He's not saying it's a bad thing. He's just telling you the conditions under which it works. In fact, perhaps really instead of thinking of it as a debt metaphor, we should think of it as a borrowing metaphor.
Okay, yeah. That's it. Lending you're borrowing from the future. This is gonna be, if you're gonna put this thing into production, you're gonna have to do all that stuff eventually. You're going to rewrite this thing or whatever. And if the business people don't understand, because they see the screen, they see it all work, and they don't understand behind the scenes all the unhappy path. I see it's the happy path, right? And the order's like, oh, it's good enough. It's good enough. It's like, okay, well, maybe it is good enough. And then maybe it's not when we put it into production and we have a bunch of customers yelling at them that our data they're failed and they can't log into their system, blah, blah, blah. because we don't have monitoring up or some kind of alarm system, blah, all the stuff, you know?
Borrowing has two sides to it. I lend and then I pay back. Okay? Yeah, so
Yeah.
somebody lends, the universe in this case, and then I pay back. There's two sides to it. People are really good at one of those sides, but not so good at the paying back bit. And he tells us, yeah, danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. That's the point.
Wow,
He's not saying it's...
yeah, the metaphor is extending the metaphor. Ward is extending the metaphor. For that person, it makes a lot of sense. But the thing is, like, we can do this for now, but eventually we're going to have to do that. And people don't hear that. They're like, oh, well, I guess we get away with it. It's like, I guess in this, and if you put the debt metaphor, people think they can get away with just like, oh, you can just get away with not paying a debt for a long time. You can refinance it. But it's like, it puts them that idea in their head when it's more like, okay, we're going to do something slapdash. We're going to put this thing together very quickly, sloppily for the mostly for the happy path. We might do a little bit of unhappy path, but mostly we're just figuring that things are going to go right. And most software is written like this. And if we get customers or we get some kind of financing or funding, whatever, then we'll start to fill out all the unhappy path and build it for like lots of people to come into the store. We're like building a facade first, which if you just touch on it, it's made out of paper mache. It'll just pop through. Get rain comes, it's gonna fall, all just melt away. That's how we build it, because we just do. People even want to come to a store like this. It's that kind of thing.
Intrinsically bad. He's referring to a concept of management, how you then manage it. He's actually saying you can take decisions intentionally and say, you know what, we don't have enough time, or more importantly, we don't have enough knowledge at this point to do a good job.
Right.
Because actually we don't know whether people want this feature, or this is the first time we've used this framework.
Exactly.
What's the probability that your code is going to be so awesome that generations to come will point to
highly
it and say,
unlikely.
that code is the best code I've ever seen?
Never.
That probability is so close to zero, we might as well call it
It's
zero.
not possible.
You've just got to say, yeah, it's the first time we're trying this. Honestly,
yeah, but the business people, they don't understand this, that we're doing knowledge work, that there's this process going on, that we have to like explore the space, and then refine it. When we find the fit, we do the refining of the space. They don't understand that. They just you get to the part where it's like you found the customers, like, okay, good, so we just refine it after. It's like, no, okay, yes, that's a part of the process, but there's this whole other thing that they have zero value of, because like, oh, I saw you do was fail a lot. It's like, yeah, that's exactly what happened. Our experiments didn't go as expected. That's most of it. And we're like, why can't you get it right? It's like, this is the job. This is how it goes. This is how the stuff's made. Zero recognition of this. Let's keep going.
We're going to learn stuff. And we should be able to update in line with our learning. And we should account for that. So, we know by definition no metaphor is perfect. And there are two common ways in which the metaphor is misapplied. Okay? Assuming technical debt is necessarily something bad. We can do good technical debt. We can have managed debt. We intentionally make a decision. We put a date in the calendar and say, yeah, let's come back and revisit that decision. Or the next sprint, we're going to pay it back.
Okay, yeah.
Well, let's review that with more knowledge.
It's just in the tacit understanding these are all experiments. All software is in motion until we abandon it. It's no software project is complete. We never have full knowledge. And the moment we do, I don't know. It's not possible. It's just there's too many variations. This style goes out of style. They want to do something new. Come on now.
Or let's get feedback from the customers. If they don't want this feature and more of it, honestly, that saves us a lot of time. We just delete it.
Correct.
Okay. We write off the debt. That's fine. We eliminate that feature. We eliminate that code. The idea is it's an invitation to a decision. It's an invitation to a path. That's the whole point of this.
It's more of experiments. It's experiments because we don't know. They don't know. Nobody knows until it's in front of them. They go, oh, yeah, that. And then they'll start picking it apart. And there's, okay, you forgot this over here, did this over there, keep this over here, put that over there. And other people say, oh, you got it. And then they'll look at your stuff and they'll try and get your customers to take away their customers or bring them back over. And then that's the whole thing. And one of those teams is going to go faster than the other. Let's keep going.
Debt is the idea that we are taking an advantage, sometimes a timing advantage. And that's often why we will use debt in the real world. Yeah. So my wife and I had a mortgage.
Or just practicality. What are you going to do? Build out every feature with all the things you need to go directly into production. With every feature, you'll never get it done. You'll never be finished.
And that was managed, and we got a house for it. That feels like a really good deal. Yeah, obviously better not to have any debt at all, but the point is it was structured, intentional, and we knew the terms and conditions that it applied, and we knew the benefit. We knew the trade-off. It's all about the trade-offs.
It's all about trade-offs. Yes, exactly. There is no perfect case. There is no 100%. There is no perfect mode business. Yeah, I mean, it looks like there might be simulate, but those little companies come in and out of business. If you look over a long period of time, the big tech companies that were giants in the 70s are gone, dinosaurs. And the new, even like car companies, like that's just. But yeah, let's keep going.
So it's not intrinsically bad. But the other thing is equating technical debt with a financial debt value. There are tools that will happily tell you, we've analyzed your code base, and guess what? You have 153,000 euros, 42 cents, sorry.
Goofy.
Right
that stuff's goofy. I appreciate the grift, whoever made that tool. I appreciate the sales cycle that got them to buy that in, and it makes sense to you talk to the right people with the management. We can calculate your technical debt budget in dollars and cents. And so it's like it's within 22 to 14%. We have 16 customers. It calculated their technical debt within 22%. It's like I appreciate the grift and this, but no, that's not how this works.
Maybe it's 41 cents. Who knows? Apparently, it can be so precise and tell you how much technical debt you have in your code.
That's ridiculous.
There's a technical term for this. Bullshit. This is pseudoscience. It's not even close to even, and I say this as somebody who takes a fairly dim view of economics. It's not even that good. It's so pseudoscientific.
Yeah.
If you say, oh, well, first of all, how do you calibrate it?
Exactly.
Yeah.
How would you know? How would you know what's what and what's what? You have to go use people, go in there and go assign dollar values? Okay, well then you're just back to the person deciding it again. And the tool's like there to help you, I guess. I don't know. Let's keep going.
I've got some duplicate code here. Oh, duplicate code is bad. Is it? Always? Sometimes duplication leads to decoupling. There's a trade-off. We duplicate here in order to decouple. Are you accounting for that? How much is that worth? Oh, here's some really bad code in a piece of code that is completely dead. What's the cost of that? The point there is there's so much here. We don't have to worry about this because it's a metaphor. It's not supposed to be an exact financial value.
Right.
It may cost
it's a metaphor. It's a conceptual model. It's a way to think about a problem, not to solve the problem. It's a way to think about solving the problem.
You may be able to recognize as a number. So we're messing up the whole thing here. So let's go back to this thing about effect and cause. Technical debt is often, when people say it, that is an effect they're experiencing. And you know what? If you have a lot of this stuff, it can become, of course, it creates a cycle. But precisely what people really need to say is they need to add one extra word. Remember the silent word I said? Unmanaged. Because if you've got managed technical, if somebody says, oh, we got technical debt in our code base. Okay, is that good or bad? What? I have actually done that with a team. They kind of looked at me like, you have no idea what we're doing. Have you come across this term, Kevlin? Sometimes act stupid. It's a really good trick. Sometimes it doesn't work. But in this case, act stupid. It's like, well, oh, is that a good thing or a bad thing that you've got technical debt? Well, yeah, it's a bad thing. Why? Oh, because it's causing so many problems. Why? Because we're not managing it. Boom, there we go. That's the problem. If somebody comes to you and says, hey,
I like this point. I've never heard anybody put this point together before, but that is true. And it's like, I've only heard people talk about, complain about it, but they don't really, they're using all these different metaphors for it. Most of, like, pretty much everybody I've asked about this does never heard about where the word Cunningham, where the term came from, or why. And there also is no plan, or it's just given lip service or glanced at it. But at the end of the sprint, if there's time at the end of the sprint, like that kind of stuff.
Technical debt, it's managed. Oh, well done. Congratulations. You've understood it. It's under control. You've worked out how it fits within your workflow. You've understood its relationship to your architecture and you as a team. Fantastic. It's the unmanaged stuff. The unmanaged stuff is the issue, which leads us to wonder, how did it become unmanaged? Now, I use the terms managed and unmanaged because they are quite...
Well, it's unmanaged, but it will be managed by someone if you let it get out of hand too much, and it stops your development cycle, allows a competitor to come up and take your lunch because you're not going to use that old processor because some new processor, they're cutting away and going right to the problem space and solution space for people and not all the other things around it. Let's keep going.
Neutral. You find there are other terms used. I know that Martin tends to use the term prudent and reckless, but the minute you say, oh, this team's got reckless technical debt, you're almost making a judgment on that team.
What does that even mean? What does
to
that
be reckless is not a good thing. Well, unless you're a teenager, in which case, of course, it's a quality that your colleagues will admire in you, perhaps. But the point there is that I want to make this neutral. Teams, there are a lot of...
Depends on what you're doing, right? If you're trying to get to product market fit and you got 2 weeks and your life's out of town, you want to try to boot up a Linux kernel, like Thompson, you're going to cut a lot of corners, man. You're going to do a lot of stuff that doesn't make any sense, and you're going to try a bunch of experiments that don't go anywhere, and then no one's going to see that, so they don't know what happened.
There are reasons that technical debt can be unmanaged, and it's not necessarily, I'm not going to blame the team. We need to understand the situation. So there is a notion here that we need to understand its impact across a number of things. If it's not being managed, then that's going to have problems. That's going to give you problems with staff retention. People are less likely to be happy with the thing that they're working on.
Yeah, man. I got to get three forms checked off by 3 layers of management. I got 6 bosses. 6 bosses, yeah, 6 bosses. Yeah, it becomes an issue. Yeah, on all this stuff because of how this stuff was built, the problems that are inherent with it, people not accepting these problems, not wanting to pay to solve them, and trying to solve them with old ways of doing it, which is this is all classic factory style stuff. all this classic business stuff, and it's like you're not addressing the main solution with it. You're building with this tooling that's not meant for what we're not fit for purpose, and you don't want to pay to do the development, the cost to make that all these kind of problems like not be issues, or you don't want to structure your people, you don't want to trust them, all that kind of stuff.
For a variety of reasons, the day-to-day doesn't feel good, but one of the most frustrating things is if you know the code can be better, if you don't know the code can be better, you lead a very happy life. Yeah, the boat's always sinking.
Blissfully ignorant.
That's just the way it is. But if you know it could be
But
gone.
you can't do that. The only people that can do that are people that are not in the code base. Managers, vice presidents, people that don't code, that don't want to do code, never heard of code, they don't care about code. They can just get the customers and the problem and for the problem space, and they get the financing and they can get the HR departments and all that stuff, but they don't know about the code, and they just have no idea. They're so blissfully ignorant. It's like, dude, a lot of this stuff requires heroic efforts to keep it going based on what you're trying to use to make this stuff. And there's like, well, it's pretty high tech. It's like, no, it's not. It's actually still mired in like 1980s stuff.
If you know it could be better, that causes you
techniques from the 80s. It hasn't really booted up. We haven't really gone beyond that. These tools and these languages and stuff, we're still writing this stuff. This like, ugh. I'm a KMP developer. I'm just like, and I've also was an early advocate or early user of HyperCard and SuperCard. It's like I saw what was possible, what you could boot up with just that stuff. And then when I saw what the Android was doing, it was like we dropped back down to like 80s style programming. Let's keep going.
Frustration. On a day, we are here, we want to be here, and we could or should be here. That difference is what causes the anxiety.
KMP and Compose is actually pretty close to what I'm thinking the flexibility we need, but still. All right, I'll quit interrupting him. Let's go.
On a day, we are here, we want to be here, and we could or should be here. That difference is what causes the anxiety or the desire for another job. Security, that's a really interesting one if you want to motivate people. Because it's very difficult to have the claim, we are totally in control of our source. Yes, we understand all the security. Yes, our code base is secure. Oh, what about this piece here? Honestly, we have no idea what it does. Well, hang on, that doesn't sit comfortably with the idea of our, we care about security.
I'm hoping the AI tools will help out with some of that stuff, but I'm not holding my breath.
We know what it does. So the point there is, it turns out you can start motivating people to manage things and to get budget for it if you need it by talking about security. Compliance, that's another good one. Defects, development, training.
What's a defect?
Pretty much everything. So this is the whole point. The technical debt metaphor is not simply a measure of the specific work needed to repay the debt. This is also how sometimes people evaluate it. I had somebody once mentioned to me, "Oh, we don't put a monetary value against our technical debt. We've got our technical debt estimated in hours. The amount of hours it will take developers to repay the debt." Well, first of all, that's not exactly your debt because it's an estimate. I mean,
which are useless.
I can say if I go to an ATM and I take money out, but honestly, I'm really struggling to remember the last time I did that. But let's just say I go check my bank account. I don't get something saying, "Oh, you've got about this much, Kevlin." It gives me an exact number, so it's not an estimate. But more to the point, it's not about the repayment. It's not simply the hours taken to repay. The whole point of the debt metaphor is the additional time and effort added to all the past work that you've done, the present and the future. That's what the debt metaphor is.
If you have to keep extending or changing or modifying that stuff, that code you wrote, you're going to just keep being painful and painful. And also the definition he uses is like the moment you know there's a better way to do it, and you're continuing to do it the old way, and you're continuing to inquire and have the pain of using it the old way, that's the technical debt as well. That debt that just you're loaded on the whole time. It's not just sitting there. It's like continuously added to the whole process until you rectify it.
It's the total cost of ownership, not the cost of today's repayment.
Right. It's like that's the word, cost of ownership. You have to keep the payments up. It's not just like payments like just sits there. It's like, no, you pay it all the whole time. Anytime you go touch that code, it's like not meant for that. It wasn't designed for that. You're trying to extend on top of it. It's got all kinds of errors. You're like putting a scaffolding around it to support it, as opposed to, why don't we just change that thing? It's like, we got $1 million in that thing. It's like, well, we're going to have to fix it. And because we're just grinding to a halt. And now there's a competitor coming up. So, well, I guess we got to fix it now.
Yvonne Lamb made this observation. My theory of tech debt is that housework is the correct metaphor for the thing we call tech debt, but we can't use it because tech has been made up of people who don't do housework or manage housework being done.
Correct. Very great. Awesome. Beautiful. Beautiful.
Yeah, and it is, isn't it? Because that's the whole point. Your household is just like, well, why are there socks on the floor? Why is the sink kind of filled with stuff? I didn't go to the kitchen to make a mess, but a mess is a side effect of the very act of doing anything that is functional. breakfast, for example.
Right. You might have had to you might have had to be late for a meeting and you needed to change your socks real quick because you stepped in a puddle and you're late to the meeting and you have to get there and you're just going to put the socks on the floor, but you can't leave the socks there. It can't be just like, okay, now we're leaving the socks on the floor from here on out. No, you have to pick up the socks eventually and have a system, or throw them in the garbage, or throw them in the wash, whatever.
There's a necessary cost that you have to put extra work in to compensate. Socks naturally gather together and they hunt in packs around the floor unless you catch them and tame them. It takes work and effort and a lot of training.
Right.
So let's look to past wisdom. I mentioned Ada Lovelace. I'm now going to mention Isabella Beeton, who actually was a contemporary, though I don't think they ever met. Sadly died very young, but she's about 30. Tuberculosis, I think, was one of the suspected causes. But she carefully disguised software engineering wisdom in a book called The Book of Household Management.
Okay.
Which was very influential in England, even into the 20th century. And when it came to kitchen advice, she absolutely nailed it. There is no work like early work.
Okay.
Clear as you go. Muddle makes more muddle. Not to wash plates and dishes soon after using makes more work. Okay. Isn't it clever, the way she gave us the advice, carefully encoded? This is software architectural, and it's encoded as how to look after your kitchen. Clever.
Okay.
Yeah? Encryption is what we call it these days. Yeah?
I mean, okay, you can care about these things, and there's practicalities, right? There's caring. Like, we want to do these things, and then there's practicalities. Like, how much budget do we have? Does this fit our goals? Can we do this? And there's the trade-off right there. It's like, well, if we try and do all the stuff we're supposed to do, we're going to run out of time and money before we're completed. So there it is. That's the problem, isn't it? We're not unlimited, infinite creatures. Damn it.
There for us to find over a century and a half later. So we have the idea that let us start from nothing and let us build stuff. If we don't clean up the kitchen, then we're going to end up with an awful lot of extra effort. This is a kind of a standard curve. We're all sick to death of exponential curves after the pandemic, but I present you with one nonetheless. The point there is, unless you do something to clear it up, you are always going to have to deal with the thing that was there before that's not quite right, even though it's well-intentioned and perhaps has the right functionality. It lacks the integrity and coherence that we want. So we might choose to say, well, every now and then we're going to clean up.
Okay.
And that gives us a benefit.
I mean, that's a rewrite. There's a rewrite. During this period, your output of new features goes down, but you're going to renew a new version. It'll come up and draw again. I think there's the only way to get through this stuff is the rewrite pattern. Or Alan Kay, where the whole system is kind of always in upward flux.
But ultimately, there is the idea of clear as you go. It's the idea of when are you doing this?
I mean, you're still going to come out here on the time frame. You're going to have to do a rewrite. So, I mean, you can extend it out further, but eventually you're going to have to. It's just the way things are, man. With these tools and how it is. Unless you're doing Alan Kay, it's like, oh, they're all popping and changing all at the same time, or they have a common API or a way of exchanging an API information for this particular system. That's the only way around it.
Always. Now, sometimes it helps to have spring cleaning and put a bit of extra effort in. Sometimes you do need to have concerted effort. Never just fall into one idea. Make sure that you have a set of ideas you can draw on for your timing. But this also takes us back to maintenance. Maintenance is an action. The problem that we are counteracting is inaction. It's a thing that we do not see. So the wonderful observation from John Seddon, value demand represents the demands customers make for the things they want, things that are of value to them. Now, John Seddon's not a software guy. I saw him speak at a Lean Kanban conference about 15 years ago. He's done work in the UK for the NHS and so on. He's a systems guy, and he kind of looks at the whole thing. And it's a very simplistic model. He breaks down demand into two things, value demand or failure demand. Failure demand is demand caused by failure to do something or do something right. The idea is, if you are thinking purely from a software development perspective, I am in front of my screen. What is the demand for my time at this point? I am adding a feature. We would like lots of our demand to be that. That's value demand. I am fixing a bug, not so much. That's failure demand, as indeed is that.
Making something new or fixing something that was already there. So his failure demand is fixing something that's broken, and value demand is like creating something new that replaces something else. Okay.
But it's not just that. I am sitting here trying to understand what I'm looking at. We've lost the knowledge. That's not valuable time. That's failure demand. In fact, it turns out failure demand is the dominant factor. Think about how much of your day you probably spend not adding value in terms of the activity.
Yeah, it's all this maintenance stuff because of how we build these things and how the techniques we use to build them up. We're not fit for what we're trying to do with them. We're hitting the edge. And the AI is going to let us go a little further beyond it, but still there's this underlying thing that has to be changed. The AI is not going to help us with that. It's just not.
It's compensating for the past, dealing with the problems there. So what we're dealing with is the fact that we missed something. There's a thing that we did not see. Right. It is not an act, it's an absence of act, it's a neglect. There's a want of
Right.
attention.
We built things on top of things on top of things on top of things, and people don't want to spend the money to rebuild this thing down here. That's why like Linux is free. It's like, whoa, there's a guy and he's Linus. He made a free operating system. Let's use that. It's like, yeah, but we need to do something more than an operating system that was invented 55 years ago, whatever. But genius. It's amazing that it lasted this long. But the core of it, we're gonna have to do some more stuff to make it so. All this stuff about maintainability, readability, all this stuff from the bottom to the top has to be kind of redone. Unfortunately, I mean, but it's maybe fortunate as well because the computer revolution hasn't hit yet.
To what ought to be done. The fact of leaving something undone or unattended to. Negligence. In other words, we just didn't see it. We didn't notice it. And what are examples of this?
Or we're doing something else at the time, and that was not a priority, which is maybe they noticed it, but like, we can't do that right now. We just need to. We're AT&T. We need to get a language out the door that's object-oriented, so we can have some sort of relevance now that we don't have the telephone network anymore, etc., etc.
Few things that we might not do: not refactoring before change, not refactoring after, not testing, not reviewing code. And all of these things, they're things we don't do, and they add a cost. It's either a knowledge cost or it's a stuff
this
cost.
is the micro level, but there's the macro level. These systems, we're relying on them. They're just not meant for what we're doing with them. We're just not designed for it. We're pushed them all the way as hard as they can, but they're not really meant for what we're trying. It's because there are so many errors, so many problems, so many security holes, so many failures. And the software is like, oh, well, you should have handled that case. You should have handled. It's like that stuff should be handled automatically already. So a lot of stuff should be higher level, like how they were doing with SuperCard and HyperCard at the time. They took that stuff higher level, and then you can still drop down to low level stuff, but most of it's this high level stuff that we're all this stuff that we're dealing with all the time. And we have to roll things from scratch all the time. It's like, what do we? And these systems are not really designed for what we're doing with them. It's like this stuff's all tacked onto the back end after as I'm like trying to solve a problem that happened way earlier. And like Alan Kay was talking about all this stuff.
The amount of stuff that we end up with. Not recording decisions. Why is the code like this? Okay, is it safe to delete this, or do we have to work around it? Not revisiting decisions. Not updating technology. Not turning down the noise. You've got
turning down the noise. What does that mean? What does that mean?
Noisy logs, noisy builds. Well, they're no use because you've learned to.
Oh, the logs. Yeah. Okay. Yeah. Well, that's where's that in academia? Where's that? Where are these classes all told? Is this academia have anything to say about this? Nope. Never heard of it. We don't know what you're talking about. What? No. Logs are really good. We have to logs a little bit. No, logs can be really bad, man. We got terabytes of logs. It's like we're charging you $30,000 a month for terabytes of logs, and no one looks at. We might look at them.
Ignore them. Yeah, we neglect them. There's loads. It's all examples. So many people would say, well, what we're describing here is technical work. And people often, when they use that terminology, say, oh, technical work. Yeah, but my product owner is going to talk about feature work.
It's all the same.
And it's presented as a false dichotomy. You could do feature work, XOR technical work. Well, I have news for you. Feature work is technical work.
Yeah.
Because in a software system, everything is made of technical stuff.
It's all knowledge work. And the marketing, sales, business people who aren't technical do not want to know how this stuff is made. They do not want to know how the sausage is ground. If they did, they would probably be like, how are you guys able to produce the stuff you're producing given those set of tools? It's like we got like nubs for fingers. It's like for the level what we're asking the machines to do versus how we have to do. It's like it's just very difficult dealing with these. A lot of these systems are buggy. They haven't been fully thought out. KMPs are refreshing. It's refreshing because it's like, okay, you guys have obviously we've worked a lot of stuff out, but it's still based on this old style from like the 80s, man. It's just all this hardware and stuff is just based on old ideas that really need to be re-looked at the core, as opposed to, well, we can just put another thing on top of it. We'll call it extra-driven development. And it's like, come on, man.
There is nothing else. There's no pixie dust. If somebody wants a feature, if there is pixie dust, honestly, go with that.
We are the pixie dust. The pixie dust is us. It's our imagination and willingness to dick with this stuff. That's our pixie. We are the pixie dust. Let's keep going.
If there is technical work if somebody wants a feature and say, do you want me to do that in a technical way or a non-technical way? The point is, it's all technical work once we are in that space because features are made of software.
Right.
So,
and ideas and concepts and taste and culture and language, region and insight, experience. It's made of all that stuff.
this is the point. I return you to this. What is lacking here is maintenance. The question is, when do we do maintenance? Well, now.
I mean,
yes, you can do.
The thing about the maintenance is it's not like this is the machine that rots, right? We already went over that. It's improving it and keeping it the system cohesive and understandable. But I don't even know if it's even possible. I think you have to just drop back down to Allen Kay. It's like individual cells, when they need to upgrade, you have to upgrade those. And if those only have a cell boundary and they interface in the system, that's how we do it. There's maintenance. I don't know.
Puns across languages. Now.
I don't know if that's a right way of thinking about it. It's like more like designing the system to be updated, extended, maintained. That's all the stuff Alan Kay talks about. Let's keep going.
I will close with a quote from Manny Dillard, the author. How we spend our days is, of course, how we spend our lives.
Yeah.
The things you do today are those things. All too often, we have these ambitions. After the next release, it'll all get better. I'll put a bit more extra time. We'll repay the technical debt. After the next minor release, major release, after the companies merge, after whatever it is, you're creating a goal that it will never arrive. Something else will happen at that point. You know this. This is the rest of your life. The point is, it doesn't take much. Just do a little thing. 5 minutes, 10 minutes. Have a chat with someone.
I mean, it's an attitude. How we approach the problem to begin with, and how much time we're allowed it, and how much, how many people we have on it, and how many ideas do we have to integrate. It's all that stuff.
Communicate about something. Make a small change. Immediately that creates, importantly, an awareness. And that's the first thing. You have to see the absence of the thing that is being done. Learn to see the neglect. It's very invisible, and it's not because people are being bad or stupid. Normally, we're in technology. We're quite smart. But we are very busy, and our attention.
Well, it's just there's trade-offs. There's trade-offs. A lot of people don't even mention what the actual trade-offs. They already know just implicitly what the trade-offs are. And we can't do everything. We're human beings. We're not unlimited. And these projects that are unlimited seem to suck as well. Like given unlimited budgets, unlimited time, they're just like, metaverse, anyone?
Attention is everywhere. So you have to learn how to see this and then learn how to respond. Thank you very much.
All right. I like Kevlin. He does good work. Hopefully this was better than the last time I not that one, silly. The last recording I did, but you did not see it. So anyway, give me a like and subscribe, and I'll talk to you soon.